Hello, everyone. My name is Matthias Muhlert. The clicker's not here. Excellent. So, whilst this is getting sorted, I'm going to introduce a little bit the topic. So, what you're going to see is I try to come up with an AI governance model. Thank you. I try to come up with an AI governance model which fits on one PowerPoint slide. So why did I try to do that? For me, it was important that you have so many stakeholders nowadays when it comes to AI. You can't expect all of them to be AI experts. But you need to include them in your strategy. You need to include them in the decision way and all this, coming to terms with AI and what it means and so forth. So I tried to do that in one slide. So that was the idea. And here is that slide. Granted, it is rather a full slide, and maybe I could have done 2 slides, but the idea was to fit it on one slide. And I will walk you now a little bit through that slide and see if you follow the path, if it helps you to get a good understanding of artificial intelligence and how you can use that slide to come up with decisions in your company to say if you actually want to use AI or not, or rather the other way, which AI you want to use and which one not. So let us start at the top. At the top, I put application. So the machine learning algorithms is the heart of it, right? But you want to attach an application to it. And that is the first path where you can decide on it. So you can decide, do I want this application actually being attached to the machine learning algorithm? Yes or no, right? That is the first step that you kind of need to choose. Should every application be attached to the machine learning algorithm? Let's quickly talk about the machine learning algorithm in the first place. So if you use a really abstract view on machine learning or artificial intelligence, what you see is that it tries to model the real world. So what do I mean by that? I mean, it is training applied to data using an algorithm. That is the most abstract way of looking at machine learning or artificial intelligence. And if we take these core components, we can then use these core components to come up with a strategy. So that's the machine learning. And the center of the machine learning, as you can see, I put the word goal. Every machine learning algorithm should actually have a goal. And this goal is really important that you actually verbalize it or that you write it actually down. Because if you don't know what you want to achieve with it, how do you want to govern the artificial intelligence in the first place? So we have the machine learning, we have the goal which has been defined, we have the application that can attach to the machine learning algorithm, and that application puts forward information towards the machine learning algorithm, right? So we have the first decision point, do we want this application? The second decision point, do we want the input that that application delivers actually be feeding into our machine learning algorithm, yes or no? So if you follow those red dotted arrows, you can then take it from decision to decision to decision. And if you're all through the path and say everyone is happy, then you actually have a good idea if you should use that AI in your company, in your organization, in your society. So that is really the core principle out of it. So let me walk you further through the whole topic. So, as you can see, I put a little bit of a coloring code. So the goal and the data has more or less the same color. Why is that important? Because the goal defines a little bit if you can actually use the data. What do I mean by data? I categorize the data into three main sections. So the first part is training data, the second part is the test data, and the third part is the validation data. So with those three little compartments of data, you can go through the whole exercise and see if you're legally using that data, if you should be using that data, and so forth. So you have the training data. Has it been acquired in a correct way? Am I actually allowed to use that data? And then you have the test data, which might look really similar to the training data, but it might be a different one just to see if actually the algorithm does its job. And then at the end, you always have the validation data, which more or less looks a little bit like true or false or gives you a result. So as you can see, if we define the goal for the machine learning in a correct way, we have a good idea if we should actually use that data. That's why, if you look at the bottom left, I put data a little bit into legal topics. Of course, the data might also have ethical topics, but let's focus with the data on the legal topic. So we went through the application to the machine learning, we went to the data. We have no red flags currently, so we can use the training data, we can use the test data, and so forth. And then we can go back to the machine learning and say, what algorithms are we actually using? So what I did here, again, I tried to work on a really abstract way so that it makes it easy for the compliance department, for the data privacy department, for the workers' councils, whatever departments might need to have a say into the artificial intelligence usage, can have a look at. So what did I do? I tried to come up with the most basic categorizations of algorithms. So we have classification, the typical spam, yes, no. We have the clustering, we have the recommendation, we have the regression, we have the decision dimension reduction, and we have the, of course, nowadays, generative AI. Generative AI, everyone is talking about it the last couple of months, so that is an interesting category. So what you can do here is work with that partner or with that company and say, what kind of algorithms are you actually using? If you ask them, can you please detail me your intellectual property of the algorithms? Can I have a look into the algorithms? They might tend to say no. But if you say, can you name the category? You can then develop a good idea if the goal can actually be achieved with this kind of algorithm. So let me do a quick example. So if we have regression, right? Regression, we're trying to identify, for example, the stock market developments, right? So we probably use a regression algorithms where we say, what can we read out of the past and predict the future? If someone then says, well, I developed something and I'm using a classification algorithm, you can then say, well, that doesn't sound logical to me, so maybe it's not a good idea. And one final interesting thing is, if they tell you what kind of algorithm they are using, you kind of also have an idea what kind of technology you need to put together. So the different algorithms have different technical requirements, and that actually makes it quite interesting to gain an understanding what kind of technology or what kind of technological stack you actually need to use. So if you have a look from the legal perspective on the data, and then from the logical perspective on the algorithm, then we come to the training itself. Also with the training, I tried to categorize it on a really high level, which makes it easy for you to talk with other practitioners, with other decision makers within your realm. So, what are the 4 most common ones? Reinforced, semi-supervised, unsupervised, and supervised. So, if we look at it, reinforced. So, reinforced is actually kind of interesting because you do more or less like a trial and error, right? So, a driverless car goes in that direction. Can it go left? No. All right. Can it go right? Yes. Okay, let's go right. So that is most of the time a typical application of reinforced learning. The reinforced learning has always a goal, right? And coming back to the machine learning goal, it can then be looked at that from that perspective. So reinforced has, if we look at it from an ethical perspective, has the question of the goal is ethical. Then we have semi-supervised, unsupervised, and supervised. Let's start with supervised. What does supervised learning mean? Supervised means a human is deciding if the machine learning algorithm is going in the right way, yes or no. So that's supervised. It tells it, you're doing it right, you're doing it correctly. But if the human is the one with supervised training algorithms who's deciding if the machine learning goes in the right direction, you kind of have the possibility that human bias will be included into the algorithm as well. So if you're worried a little bit about human bias being introduced, especially watch out by supervised learning. Unsupervised and semi-supervised are then, of course, the mixture. So unsupervised means you actually don't tell the machine how to think or where to go. You see what it comes up with in itself. So how does it itself label the data? This has a fantastic opportunity, especially if we look at disciplines like medicine, right? So machine learning algorithms can get lots of data in from medical files and then come up with new strategies to cure certain things or detect certain things. So that is really, really great. And you have the less amount of human bias. And then, yeah, of course, you have the mixture between unsupervised, so without human bias, and supervised with a lot of human bias. And then going semi-supervised, which basically means time saving because you don't do every operation where someone looks over it, but you do it for maybe 50% of the time. So therefore, you have semi-supervised. So if we go again, so application, what kind of input, machine learning, what is the goal, to the data, can we actually use the data? Are we allowed to use the data? Is it correct to use the data? Going back to the algorithm, thinking about, is it logical that we actually use that algorithm? And then going back to the training and say, within the training, okay, does it have any human bias? Do we have any ethical topics here that might come up and show in that direction? So if we have no red flags up till now, we come then to the last decision point. And the last decision point is actually called decision, or at least in my governance model it's called decision, because it gives you the opportunity to think about it if a human should intervene with the decision or no, right? So is it time critical? And if things are time critical, always keep in mind that the decisions are most of the time not made by a human, but the decisions are made by the machine. The less time critical is, the more time you actually have, and think about how can we use this decision. So let us think about that. So in the last point, just think about before you act, does a human intervention is necessary, yes or no? Let us do, for example, a modern company uses machine learning algorithms when they are hiring people, right? So they use a lot of data to analyze, to see if someone is lying during the job interview, or what kind of emotion someone has during that job interview, right? So that's all within the data. So how do we acquire this information? Was it ours to use? Then what kind of algorithms might be useful, right? So it is most of the time it's more or less like dimension reduction, right? Because you have so many facial and micro expressions and where the eye movements are and all this kind of things. So you need to do like dimension reduction or recommendation algorithm. So you say, okay, that makes sense. And then you do the training. And then you think like, okay, where do I put the training in? Where do I have a human to decide yes or no if that makes sense or if it doesn't make sense? But then coming to the last point, the decision. So we have this modern company, they're using machine learning algorithms to decide if they should hire someone, yes or no. So, and here is really the human intervention, right? If the machine says yes, should you actually hire this person? If the machine says no, should you actually disregard the idea of hiring that person? So you have the possibility to do that in that governance model. So it is a full picture, granted, but you have a governance model on one single page. You have a governance model with that where you don't need hundreds of white papers to read to get a good understanding of artificial intelligence and all this kind of stuff. And you can come together to a conclusion what you want to do with that. Once you internalize a little bit the governance model, there might be actually additional benefits that you can use that for. So when I was thinking about that model, I said, well, I can properly extend it to a risk model. So if we think about risk, it's not a complete risk model, granted, but if you think about it, you can maybe determine where someone might attack your artificial intelligence. How do we want to do that in that simple model? Well, if we say, let's assume the data, right? If an attacker needs to invest less than you in coming up with data, right? He has a high possibility to attack you there, right? If the investment of the hacker is low, yours is high, then the possibility that you get attacked on the data is probably also high. If the attacker, for example, has an algorithm attack, had anyone experience with a sponge attack? Do you guys know sponge attacks? It's not from the cartoon. It's basically an attack on the algorithm where you use up all its calculation power. So you come up with a little piece of algorithm yourself, you introduce it to your algorithm, and all of a sudden your machine is going down and down and down. And those are sponge attacks, right? So really interesting to look out for when it comes to algorithms. And sponge attacks are really that interesting part for me where the effort of the attacker is low and your effort is really high, and therefore it might be that an attacker is attacking you exactly on the algorithm. Same is true for the training. If you need to invest a lot into training times, and whoever has bought tokens for calculation times in Google Cloud and so forth, you know that it costs a lot of time and money. But if the attacker only needs a really short amount of additional training time to disturb your whole model, you might get attacked on this. So if you internalize a little bit the model with, okay, we have training, we have data, we have algorithms, you can use that actually to do a little bit of a risk modeling as well. And I thought that is quite an interesting idea. If the attacks are then technical feasible, is of course for an expert to judge, but it can be made really interesting. So, this is the governance model used in another realm. Of course, for complete risk model, you're only calculating the likelihood here, not the impact, right? So if the impact is low, then the risk is still low, right? So, what is a little bit my idea is we can come up with questions that we kind of need to ask on the different paths. And the more questions you develop, the more easy for you it will be to come up with a decision where you say, yes, we inspected this artificial intelligence before it went live, and yes, we're confident that we're going in the right direction. And that, for me, is the beauty of it. And if you come up with more questions, please feel free to drop me a line. I will happily include them. So I see this more or less as an AI governance model that is open for everyone. I don't have any intent to earn money out of it. I already have a good job. So, but this is something where I want to give to you, to everyone, to gain an idea, either if you're subject of AI or if you want to use it, or whatever. So, please use it, give me feedback. I'm happy to develop it further, but it should give you an idea on how multiple stakeholders within your organization, within your country, within your society can be included on a topic that is obviously close to all of our hearts, because it's going to revolutionize quite a lot of things. So, for that, just a closing remark, more or less. AI governance, I see the responsibilities on 3 layers. I see the responsibilities within the society, I see it within the organization, but also within the individual. If you're a subject of AI because you went to a job interview, coming back to the example I put forward early on, you should be capable of asking those kind of questions. How did you gain the data? What is actually the goal here? Who's making the decision? What kind of algorithms are you using? You should at least be capable of asking those questions. And if the answers are not satisfactory, because you're, then you should probably take it up and say, well, I'm feeling not comfortable being subject of this artificial intelligence. So organization and society, of course, is also responsible to come up with regulations, to come up with ideas how this can be done. And with this kind of model, hopefully you will have the possibility to include as many stakeholders as possible. So that is more or less my wrap-up. It's one of the topics I'm currently thinking of. Another topic that I'm currently thinking of, so if you Google my name, Matthias Muhlert, there might show up a term which is called cyber fantastic. So cyber fantastic is my new way of thinking on the cyber evolution. So for all the big tech companies or the big organizations, if you fancy talking about cyber fantastic, I created a little lovely logo on it as well. Please join me and read the white paper, give me feedback on the white paper on cyber fantastic as well. But also, please let me know if you can use that AI governance model. Hook me up on LinkedIn, and if you need further information, if you need further assistant ideas, if I should talk with your companies, please let me know. This is a general offer to the great security community here at Black Hat. So with that, I have 10 seconds left. I thank you very much for your attention. Please grab me, please have a discussion on it. and I thank you very, very much.